Hello, welcome to a sort of special edition. This is kind of my holiday best of the year kind of video where I try to highlight some puzzles that have stuck with me. They've been sticking in my brain for one reason or another over the course of the year, and that really not many people have seen. So this puzzle in particular, called Second Law by jsmirob, I think it has 20 solves, maybe 21 on Logic Masters Germany. I haven't seen it. I mean, it's possible that someone else has streamed it, but I haven't seen it featured anywhere. And it's just, I think it's just a gorgeous, gorgeous puzzle. Much like the name, which I assume is named after the second law of thermodynamics. You end up with, which describes kind of how heat can flow, or energy can flow between different heat sources and sinks. You see digits kind of flowing throughout the puzzle, and it just is incredible. And I solved this in July, I think, and it's still in my head. Um, so I'm just going to get into it because I want to describe the puzzle and not my feelings about it. So rules are fairly straightforward, right? I've got normal Sudoku rules and these arrows. So and this is the standard arrow rule, so if you've seen it before, skip ahead. But basically, the digit in the circle has to equal the sum of the digits in any particular arrow. So if this is a 6, then these two digits would have to sum to 6, and maybe it's a 1 and a 5. These two digits would also have to sum to 6, maybe a 2 and a 4. These two digits would also have to sum to 6, and maybe a 1 and a 5. And that's it. Those are the constraints. And I mean, these arrows are kind of busy, but there aren't that many of them, and hopefully we'll see. Hopefully you'll see and agree the beauty of this particular puzzle. So and the way I'm going to try to format this is as I walk through the steps here, I'm going to try to give you a warning to maybe pause and think about how you might solve the next step of this puzzle, and I'll give some layered hints to think about where to go next. And so the first step of this puzzle is that you can actually place a digit right away. You can place one digit right away in this puzzle just from the arrow constraints. So that's my vague hint number one. And then my deeper hint, if you haven't paused yet, is it's actually this digit here. So what is it? It's a 9. And so, I mean, if you have a situation where arrows can constrain a digit, it's almost always going to be the highest to the lowest digit. So maybe not a surprise it's going to be a 9. So why is this a 9? Well, it's because of all the arrows coming off of this and the exact way that they're arranged. So I've got 3 arrows in the box. These all see each other. So I need this digit has to have at least 3 different ways that I can use the digits 1 to 8 to sum to it, which means it's at least 7 right off the bat from these 3 arrows. Because if I have a 6, the only way to sum there with unique digits is 1, 5, 2, 4, and then I got nothing else. We're out of digits. So I need at least 7. And then this arrow here means I actually need a 4th way, because the 2 digits on this arrow see 1 digit from each of the arrows, right? It sees this digit on this arrow, this digit here, and this digit here. So if you're having trouble seeing why that matters, let's say this were a 7, or 8 even. How do I sum to 8? There's 3 ways. I can have 1, 7, I can have 2, 6, and I can have 3, 5. And I'm arbitrarily placing these, and it doesn't matter how you place it, right? The same logic is going to apply. What do I put here? Can't put 1, 7, that'll break this. Can't do 2, 6, that'll break this. Can't put 3, 5, that'll break this. So this actually has to be a 9. So that's step 1. And quite beautifully, if these arrows were arranged basically any other way, right? If this arrow, if this were just straight down and straight diagonally, right? Then this arrow wouldn't see this arrow, and this actually could be a 7. So it's it's a somewhat unique construction that allows this to happen. So I've got the 9 placed. And the next thing you're going to do is look at, well, okay, what does this 9 give? Because none of the other arrows actually give you any immediate deductions. So what does this 9 tell me? Where is it looking that we'll put some pretty strong restriction on where 9 can go in a row, column, or box? And the answer is, well, let's look up into box 1, right? So 9 can't go any of those places. It can't go on the arrow itself because this circle has to be bigger than the digits on the arrow, because the digits on the arrow, right? This digit sums with at least 1 to get this digit. So this has to be bigger. The circle has to be bigger than the digit on the arrow. So 9 can't go. 9 can't go on the arrow because then the circle would have to be bigger than 9. So 9 goes here. And now we get to the hardest part of the puzzle, which is not the most beautiful part, I don't think. And it's a kind of construction that I've seen before. So when I actually saw this puzzle, I kind of knew what to do already because I'd seen this exact is too strong word, but I'd seen a very similar logical construction in another puzzle. So what do you do next? It's if you don't see it, do not beat yourself up. It's very, very hard. It's very, very hard. And I think actually maybe I saw Simon doing a Cracking the Cryptic first, which is why I had thought about how to do it here. So the first layer of hint is, well, these arrows, we've got 4 of them, they're kind of vaguely looking at each other. That actually going to put quite a bit of restriction on these circles. That's the vaguest hint I can think of how to give for what to do next. And the next layer of hint is, think about what these 8 digits could possibly be. And more specifically, how many of these digits can be repeats? How many of these 8 digits can be repeats? So if you figured out that the answer is 1, good job. Very hard deduction. So why can it only be 1? Well, suppose that I have 2, right? Then let's say this is 1. Then where does that repeated digit go in box 2? Well, it doesn't go here, it doesn't go here. It's got to go in the center. Right, sorry. It's got to go in the center of box 2 somewhere. But it can't go in the circles, right? Why? It can't go in the circles because the circles have to be bigger than the digits on the arrow. So if the digit's here, it can't also be on the circle. If the digit's here, it can't also be on the circle. So any repeated digit, right, if I put it here, the repeated digit has to go on the other row in that arrow. And so in box 2, it's going to have to go right here. It's the only possible place. If I have a repeated digit, it goes here. So I can only have 1 possible repeated digit. So that's only step 1 of this next deduction. So that's step 1. I can only have 1 repeated digit. Okay. Now from there, I actually know, I don't know which way it goes yet, but I know the 2 digits that go in these cells. So I'll give you another chance to pause and think about it. I'm not going to do a more specific hint. Or maybe I will. So the next specific hint is, well, because if we have this constraint, the logical thing to think of is, well, how large can this be? And then you would contrast that against, well, how small can this be? Well, how large can this be? 15, right? Right. The highest this could be is an 8-7 pair because of this 9 here. So the highest this can be is 15. What's the smallest this can be? We said we have at most 1 repeated digit, so there are at least 7 unique digits. So the smallest those could be is 1 to 7. That sums to 28. Then I've got a repeated digit. The smallest I can make that is another 1. So that would be 29. So the smallest this could be is 29. But that's not quite true. The smallest this can be is actually 30. Why 30? These 8 digits rather, can't be odd collectively. Why not? Well, these 4 digits sum to whatever this sum is, right? Because these sum to this, these sum to this. So these 4 sum to the sum of those 2. These 4 also sum to those same 2 circles. So these 8 digits sum to whatever these circles are doubled. And that doubled number is going to be even. So these have to be even. And so it's at least 30. Well, So the smallest this can be is 30. The largest this can be is 15, which doubled, which will be the sum of this, is also 30. So that is just what it has to be. Here I have to have 8, 7, and these have to sum to 30. And now, how do I sum to 30 with those 8 digits with at most one repeat? Well, I guess there are actually 2 ways to do that. One is I could have the digits 1 to 6 and 8, so skip a 7, right? And then repeat 1. That's one way to get to 30. But I can't put an 8 on this arrow because if I do that, that'll break. This circle has to be 9. It just doesn't work. So that way doesn't work. The other way to do it is to have 1 to 7, which sums to 28, and then repeat the 2. So we actually get a repeated 2, not a repeated 1 here, which I think is very cool. It relies on this, like, often in these kind of sudoku constraints, if you have kind of 1 degree of freedom, meaning you've got like 1 extra way of making things, it actually that only gives you like 1 extra combination of ways to something. Not all the time, but that's often the way things work out. And so I really like when you can make a deduction even though you seemingly have that 1 degree of freedom there. So this can be a 2. Okay. So next step, and again, I'll give some layered hints. I've got a bunch of information about digits in this row now. I've got a 9 here, a 7, 8 pair here, and this 2. So the vaguest hint I will say is, now that I have kind of digits placed in here, can I use those to restrict where those digits might go in other places, other rows, boxes, or columns? And in general, that is always how you should be approaching these problems, is once you reveal some new information, how does that information let you provide restrictions somewhere else in the puzzle? And so if you've already found it, amazing. I'm going to do one more hint, which is, where can these digits go in box 3 specifically? And then the final hint is, where do the digits 8 and 9 go in box 3? Well, where does 9 go? These 9s mean they can't go here. They can't go on the arrow. So 9 has to go in one of those 2 spots. 8, same exact story. I can't have 8 in the column because it's a 7, 8 pair. I can't put 8 on the arrow because this would have to be bigger than 8. So 8 is also in one of those 2 spots. So these are actually just an 8, 9 pair. And now, where do I put 7 in this box? Well, the answer is, anywhere, I guess. But if this arrow circle is a 7, that eliminates 7 from anywhere in this box that it could possibly go. So now this has to be 8, this has to be 7. Right, this has to be 8, this has to be 7. And now I can do some more work over here, but I'm actually gonna skip to another step which we can already do. In fact, I didn't even have to do this step yet, so I'll back that out. So you can see you don't even need to do that yet for this other step, which I think this next step is just an amazing work-up construction. It's absolutely beautiful. It is not quite as hard as seeing this deduction, although it's somewhat similar. And it's a way of doing it that I've never seen before. So anyway, let's get some hints. So first of all, this 8, 9 pair looks down and sees this arrow, right? This arrow circle. And that's going to put a lot of restriction here. Because what can go here? Well, I need at least 3 ways of constructing this sum, right? Here's one arrow. This arrow has to be different than this one because this cell sees everything on that arrow. This arrow also has to be different from this one because this cell sees both of these. But these 2 also have to be different. Right? These 2 also have to be different. It took me a while to see that. So I'll let you pause the video and think, well, why do those 2 actually have to be different? And the answer is, this cell sees both of these. Right? This cell sees both of these. So these 2 arrows can't be the same. So I need 3 different ways of constructing this sum, whatever it is. And if you're like me, when I first did this puzzle, you might think, oh, then it's a 7. Because I need to put a 7 there, because that's the only way to have 3 different ways to sum to a specific digit, given that 8 and 9 are gone. Right? It needs to be at least 7. And you, like me, would be incorrect, because you didn't think about the fact that these arrows cross the box diagonally. Right? So this could be a 6, right? I could have 3s going along an arrow like that. And I could have now 3 different ways of getting a 6. 1, 5, 2, 4, and 3, 3. So I can actually only limit this to 6 or 7, but that's not the beautiful part. That's not the hard part. The beautiful hard part is it's actually not 7. It's not 7. And I would love if you took a second and tried to think about why. And I'll give some more layered hints about why this isn't 7. And first hint is, remember, these 3 arrows all have to be different ways of summing. So these are the digits 1 to 6, and they're all unique. That's hint 1. Hint 2 is, now think about these particular digits. I won't even color them for now. Purple and blue. And the final hint is, where do these digits go in box 9? Well, I'll give one more hint after that. And then the last hint is, where do those digits go in box 3? Right? I mean, in a lot of Sudoku, the trick is, can you figure out how to ask the right question? It's a very hard skill to develop. I mean, for me at least, it's mostly pattern recognition. But you see things similar to other things that you've done before, and that triggers some kind of memory to get there. So where do these digits go in box 9? Well, if this is a 7, if this is a 7, then these digits can't go on the arrows in here, because remember, these would have to be all unique digits 1 to 6. So I have 3 different ways of summing to 7 here. These are all unique. So purple can't go here, can't go on an arrow, can't be 7. So it's got to go here. Blue, I don't know exactly where it goes, but it's not in the arrow and it's not 7. So it goes in here. Now, where do these go? So far, fine. No problem. Where do blue and purple go in box 3? Well, blue goes here. Can't be 8 or 9, so it's got to go there. Purple, same story. Here, can't be 8 or 9. So blue and purple would both have to go here. Breaks. So this is in fact not a 7. This is a 6. Right? And so I know that one of these diagonal arrows is going to be, that leaves the box, is going to be 2 3s. And I actually know which one. Right? I know which one. And I'll give you a second to think about, pause the video. Which one is it? And the hint is, do the exact same thing we just tried, but now with a double 3. Right, so what you'll see is, if you make pink or purple, I don't know which this is, whether they call it pink or purple. If you call this color 3, then 3 goes here. But blue now, being 1, 2, 4, or 5, still can't go on any of these other arrows. Can't go here. So blue is going to go over here. And if you do that, you get the exact same problem, where 3 has to go here in box 3, and whatever this blue digit is also has to go here. So that's going to break. And so what you actually find is that blue is 3. These digits are 3. And then these are all now 1, 2, 4, 5 in some order. And just like for the reason we've been saying, this is also, the pink has to go here because it can't repeat on these arrows, and that makes this 7, 8, 9. And now I'll go back and I'll fill in with this, because this is kind of the next step here. I have to do 8 and 7 here. And, okay, now we need to think about these arrow digits and what they're going to be. Remember, these are the digits 1 to 7 and 2 twice. Now, because there's 2 twice, on the 8, I'm going to have a 2, 6 pair somewhere. There has to be a 2. That's going to get paired with 6. Here I'm going to have 2 and 5 set up. And then to get the other sum, there's 2 ways you can think about it. One is, well, 5 is taken, so this can't be 3, 5. It's got to be 1, 7. The other way to think about it is, where does the 7 go? It doesn't go on the 7. It goes over here, so that's 1, 7. Either way, you get to come to the same answer. And the 3 and 4 that are left go over here. And now that tells me information about what goes here. So what's left is 3, 4, 5. These 3's actually tell me where the 3 goes here, right? And now I know what these digits are, right? They are 1, 6, and 9. And that puts digits here, 7 and 8. Kind of brushing through this because it's all just kind of Sudoku. If you want to do some Sudoku, you can pause the video and do some more. But the next step here now, it's actually not Sudoku, so I shouldn't have told you to pause just then. At least for me, it's not Sudoku. The next step here is to think about this arrow. Why this arrow? Well, where do these digits go in box 7? I'm going to call these blue, right? Where do these digits go in box 7? They're blue. And we already said that, so another thing to kind of know about Sudoku is that you can use the digits 1 to 8 to sum to 9 4 times exactly and use them all, right? You have 1, 8, 2, 7, 3, 6, 4, 5. They all kind of sum up to 9. And since these arrows are all unique, these 4 arrows, like we said before, and this particular thing we could have done earlier, but we're going to need it soon, so we'll do it now, is these 2 digits won't end up on any of these arrows, and they also won't be 9. So these 2 digits both go here. And now that means where do they go in box 3? They go up here. And so now I actually know, I could have done the blue highlighting earlier, but now I actually know what those blue digits are. So go ahead and pause it for a second. See if you can figure out what are the blue digits. And they are 1 and 8. That's the only 2 digits you can take from this set of 4 that will sum to 9. So this is 1, 8. This is 1, 8. And now you can actually place another digit. Pause it, see if you can find it. You can place the 1 because where 1 is now in blue has to go in here. This is a 7, 8 pair, so that's the 1. I'm going to actually delete the blue highlighting because it's done what we needed it to do. And I puzzled that I did that blue highlighting fairly early, and so it was there for a while. But it illustrates the point, but once we have the digits, it's not really necessary. Okay. And now something else we could have done as we filled it in is actually know a little bit more about what this digit is, right? Because this digit actually ends up in column 9, box 3 here. So these digits are not 1, 2, which means this is 1, 2. Right? That is 1 or 2. So that is the next step. And now, finally, I think I can also place this, right? My walkthrough notes are not, I'm looking at my walkthrough notes and they're not quite good enough. I think I can actually figure out which way these go as well, right? Because, so I'll let you think about it. You can pause the video. Which of these, and by which way around it is, I mean, I know which one is the low, the 1 or 2, and which one is the high. And the way you know that is, I've got a 4 or 5 pair now, here. So that's not 4 or 5. That's not 1 or 2. Okay, so now I've got, so now again, think about what new information did I just get, right? And then how can I use that to my advantage? And what I just found is that I now have a 4 or 5 pair. I guess there are a couple. I have a 4 or 5 pair in column 9 as well. It's not going to end up being as useful, but that will tell me these 3 digits, right? This is 3, 1, 2, 7. And I've got a 4 or 5 pair here, which will be very useful. Did you see it? This tells me where the 4, 5 arrow is on this 9. Right? Because now it's not this arrow. It is not this arrow, because this digit can't be 4 or 5. This digit can't be 4 or 5. So the 4, 5 goes up here. Right? And then I can do a little bit more here, which will help me clean up later. Right? This 6 means one of these is a 6, which means the 3 it pairs with is up here. And then this 7, 8 pair means the 7 is not here, so it's over here. And the 2 it pairs with will go on the other side because of these crisscrossing arrows. So this doesn't really help me, except later it'll clean up nicely if I have those marked already. Okay, now the question is, and I can do a little more here, right? This 1, 2 pair will clean up this a little bit. That'll let me fill in this is 8, 9, and this has to have a 6 with 4 or 5. There's a few more markings now. Okay, now the question is, I added this, so all of that was kind of extra work we didn't need to do, but it'll make things easier later. I've got this 4 or 5 arrow that I just made here, and I've got another 4 or 5 pair here. Those both look into box 8, so 4 and 5 are both going to go in here. Now, why does that matter? Let's think about what goes here. I've got a 6. I've got 1 or 2, whatever's missing from here, right? And I've got 7 or 8, whatever's missing from this cell. Right, that's what's here. So why does that matter? Because I have 4 and 5 in this row, one of them has to go on an arrow tip, right? I can't put them both in the middle. Right? One of them has to go on an arrow tip. And whatever goes on the arrow tip can't go with 6, right? Even 4 can't go with 6. Can't go with 7, can't go with 8. It has to go with 1 or 2. So 1 or 2 can't be in the middle. But 1 or 2 is going to be on the arrow tip with the 4 or the 5. Okay. Well, that actually tells me something about what this arrow can be, right? The smallest it can be is 5, right? If I have 1, 4. The largest it can be is 7, right? If it were 5, 2. So this is 4, 5, 6, or 7. Well, it can't be 6, I'll tell you right now. And so I'll give you a second to think, why can't it be 6? Well, it can't be 6 because if it were 6, then it would see all 3 of these 6s, right? It would see this. I mean, see is not quite the right word, but by sudoku, this would, if this were 6, then by sudoku that's not 6. But also, these can't be 6 either. In fact, they couldn't be 7 or 8 as well. They'd have to be 1, 2. And that would just break this. But more importantly, or more directly here, 6 can't go in the box. All right. Now, I'll leave it to you. Can it be 4 or 5? Pause it if you don't see it immediately. It's not that hard, but pause it if you don't see it immediately. Why can't it be 4 or 5 either? And it can't be 4 or 5 either because of the reason I said before. If it's 4 or 5, neither of these are 6. They're not 7 or 8. Right, if we have this situation, because they have to be less than 4 or 5. And so that's going to break. I have 3 cells that all need to be 1 or 2. That doesn't work. So this is in fact a 7. Making this 1, 2, or 3, but it can't be a 3. So now this is 5 or 6. And then these now can't be 7 or 8 because this is 7. And so these digits I have this 1, 2, 6 triple, which means this is now an 8, making this a 7. And then now I know that these are actually a 5, 2 pair, right? Because we have 4 and 5 pairing with 1 or 2, right? So it's got to be 5 pairing with 2, and then we actually end up with 6 pairing with 1. So these aren't 4, this is 4. And these aren't 1, right? We have 5 pairing with 2 and 6 pairing with 1. That makes this 1 and 2. On my walkthrough sheet, I actually have a thing that says, check your arrows, because every time I do this, I'll often fill in this. But then I mean, here I have it labeled in pink, so it's obvious that those are also 5s. But I forget that this is a 5 because this is a 1. And then I'm like, where do I go next? This is actually the second time I tried recording this for not that reason, but I have that written down because I had some trouble remembering that as I was resolving this to make sure I could do it again. And then that this 2 is actually going to fix all this over here. And that fixes this. And I know now what these digits are, right? Because I have the other 6 here. So what's left is 3, 7, or 9. These can't be 7. Oops. So this actually is the 7. This 3, 9 pair tells me how this goes, which tells me how this goes. And then what I'm going to do next is think a little bit more about how to place some more digits. So I was going to do a little bit of Sudoku for a bit. So if you want to pause and just do some more Sudoku, you can. So these are 4, 5, 6. And I can get rid of one of each of those. This is either 2 or 3. How do I know that? Well, think about what has to go here. I have to have a 9, right? I have to have a 7. And now because I have these 4s and 5s here, I know exactly one of these is 4 and 5. Exactly one of these is 4 or 5. And so the other one is going to be 2 or 3, right? So either way, let me be a little more careful. How do I know what this is? It's either 2, 3, 4, or 5, right? But it's actually not 4 or 5. How do I know that? Well, if this is 4 or 5, and I have a 4 or 5 pair here, that makes these both 2, 3. That makes these both 4 or 5, which breaks this cell. Right, so this can't be 4 or 5. It's actually 2 or 3. And the other 2 or 3, or easier, I can just look over here. And then I end up with the other 2 or 3 over here. Okay, but I have this 1, 2 pair. And actually, I should have listened to myself. Walkthrough says, look at the arrows. They check, they reveal everything. So that has to be a 1. That has to be a 2. That fixes this. That fixes this. And puts the 9 in. Yeah. And that gives me even more. So this is all just some Sudoku. Okay. And now I think I need to do the scary step. Which is it's kind of Sudoku. I mean, it's pretty basic Sudoku, but it was very hard for me to see for a bit. And I'll give you a hint. It has to do with ones. And so often what I do in a situation like this is I'll kind of highlight ones and see if I can figure out where things need to go. And as you're looking at this, you think, well, I've got ones could go here or here. I've got this classic X-wing that doesn't resolve. But I can't put the 1 here because that will put another 1 there by the arrow. Because this 1-digit arrow essentially says, these have to repeat because this just has to equal this. There's only 1 digit on the arrow. So they're the same. That's 1, that's 1, that breaks. So I put the 1 up here. That's going to resolve all of this. Right? And now I know what goes here. That's just 5 or 9, but I know which way it goes. And this becomes 3, 4, or 6. Well, actually, I don't know yet which way it goes. When I did this before, I knew which way it went right now. So I've got to do a little more Sudoku. These are also 3, 4, 6. Here, I've got 4 or 6, but I know which way it goes because of the 6 or 4. It's all just Sudoku at this point. Right, that's going to place. What do I have left? I have 2, 5, 8, 9, and I just know where those go. And that is the puzzle. And this is one of my favorite puzzles of the year. I really hope you tried it yourself, or at the very least that you took a second to think about the points where I stopped and how that might work. I think it has a really beautiful flow to it. How you might, the 9 tells you that the 9 has to go here, which has this really complicated interaction with these double arrows. And then that puts 8, 9 in the corners here of box 3. That tells me about the 6, right? And that all kind of flows back through. We get 7, 8 down here, which tells me about an 8, 1 pair here. Right? It's a beautiful flowing Sudoku that takes you all around the board with a very limited rule set. And it's just one of my favorites, and I hope that you appreciate it as much as I do. So thanks for watching. Have a great holiday.